The liquid and solid phases are called the condensed phases of matter. This is because matter in these phases occupies relatively smaller volumes than in the gaseous phase. We can easily observe and identify these condensed phases. A gas, like the air around the solid and liquid you see, cannot be observed as easily unless it is colored. But we can infer its presence in other ways. Arceli de Silva has here 2 empty dry bottles. She fills bottle A with tap water and bottle B with cracked ice. She then covers each bottle tightly and wipes the outside wall dry. Observe what happens. Droplets of water form on the outside wall of bottle B. We find no such droplets on bottle A. Where did all these water droplets come from? Could they have come from inside the bottle? Not at all, since the bottle is tightly covered. They could have come only from the outside. These droplets used to be part of the water vapor in the air outside the bottle, but they condensed or turned from gas to liquid due to the low temperature of the bottle. In the case of bottle A, the temperature of its wall is not low enough to condense any water vapor surrounding it. Vapor is any substance in its gas phase that exists either as a liquid or solid at room temperature, as in water vapor or alcohol vapor. We use the term gas for substances that exist as gases at room temperature, like oxygen or carbon dioxide gases. Water is colorless. That is why we cannot see it in its vapor phase. But some gases are colored, like bromine, chlorine, and nitrogen dioxide. Unlike solids and liquids, gases tend to diffuse or spread out even in a space already occupied by another gas, like the perfume that fills the air in a room. Because of this tendency to spread, gases have no definite shape or volume. When confined in a closed container, they will always fill up that container. We can fill a container with as much gas as the strength of the container will allow, and we call this property compressibility. We can fill tires or balloons with air, but there is a limit to the amount of air we can compress into a tire or balloon. Once we go over this limit, the tire or balloon will burst. That is, air inside suddenly expands. Then, accidents like this, due to blow-ups of tires, will happen. Substances in a gas phase, like the helium in this balloon, are always lighter than when in a solid or liquid phase. Gases have different densities. The balloon rises in air because the gas inside, usually helium, is less dense than air.